Hey everybody, so today we're going to be learning from Chapter 6, Lesson 4. We're still on the concept of writing expressions, which we just did in our inquiry lab. Okay, so Algebra Writing Expressions is our title. Don't forget Chapter 6, Lesson 4. I have my notes divided in the main ideas column and notes column, and we are really just building on what we learned in the inquiry lab, which was translating what we understand from words and situations into numbers and operations. Okay, so we are creating algebraic expressions. And just a little review on what an algebraic expression is. You can find it in Lesson 3 of Chapter 6. An algebraic expression has at least one variable and has at least one operation. Okay, so let's start writing our notes. So we are going to work on translating words into an algebraic expression. Okay, and we just defined what an algebraic expression is and where you can find it if you have any questions about it. Okay, now we're going to write down the process of how to translate words into an algebraic expression right here. Okay, so first you're given words, which are, and you're going to be given some keywords. So you're going to be given like a sentence, and within that sentence you're going to find a lot of keywords that's going to help you translate that information into an algebraic expression. Okay, then we are going to define the variable. Okay, so the variable is going to be something that we don't know. It's going to be an unknown number of something, and we have to define it. You can represent the variable as any number in the alphabet. Just remember, we don't want to use the letter O because it looks like a 0. But you can use any letter in the alphabet. We are going to model. So those diagrams that we were drawing or that you saw in the inquiry lab, that would be modeling the situation. Okay, so, and the model is optional. So if you don't like using a visual, you don't have to do it. If you do like using a visual, feel free to draw a diagram. And last step is going to be to create your algebraic expression. Okay, so now that we have our 4 steps, which are identify the words, keywords, define the variable, model if you choose to, and then the algebraic expression. Now let's talk about some of our keywords over here. Okay, and then we will get into discussing some examples. So I'm just going to make a line here separating what we did over here from our keywords. Go ahead and put keywords at the top. Okay, so with our keywords, okay, our keywords represent an operation. Okay, and we talked about what operations are. Operations are addition, subtraction, multiplication, and division. Okay, so let's start with addition. There are going to be words in a situation that tells you if you're adding, and in this case, those words are going to be more than. So if something is more than something else, an increase, greater than, and add. Okay, so those are just some words that could make us think of addition, okay, or give us a hint that we're adding. And I apologize, I have to write small over here. I can kind of bring the computer closer at the end of the lesson though. So more than, an increase, greater than, and add, those all tell us that we are adding. Just going to highlight that. Okay, so then next we are also going to be told in our keywords when we are subtracting. Okay, so some words to identify if we are subtracting is going to be fewer than, less than, subtracted, minus, and decrease. Okay, so like I have fewer than or less than, there's a decrease. If you hear those words, that's going to tell you that you are subtracting. And if at any time you find another keyword that you know means subtract, then feel free to add it to our word list. Okay. And of course, we need to take notes on some keywords of multiplication. Okay, so in multiplication, sometimes it'll say blank times. So blank times something, and we know that it means multiply. You'll also hear multiply. Multiplied by, and doubled. Doubled just means times 2. So in parentheses, I'm going to put times 2. Tripled. Tripled just means times 3. Okay, and twice. Twice also means times 2. Just another way to say doubled. All right, and the last one, division. Here's our word list, which is going to be divided by, blank, like you divide by 2. For example, half as much. Okay, half as much, you're dividing by 2. And then, again, if you find any other words for either adding, subtracting, multiplying, or dividing, you can add them yourself to your own list. Okay. Just going to kind of color code this. So I'm color coding it, and I'm using specific colors because when we're going through our examples, I want to use the same colors to show us if we are subtracting, adding, multiplying. So use your colors with purpose today. And I will bring the computer forward so you can read this a little bit better. Okay, so let me just bring that in. And if you want, go ahead and pause it. Okay. So now that we have all the basic information that we need to really work on a problem, let's start with our examples. Okay, so we are going to start with our word problems, okay? And I'm going to divide this paper in half so that we have enough space for both of the problems, and just know we are working on 2 problems. Okay, so here's example 1. Okay, in example 1, we have $6 less than the original price. Okay, so that's our situation, that we have $6 less than the original price. So right away, I see words that kind of stand out to me, and I see some key words. Okay, first I see less than. I remember this less than is from our keyword list in the subtraction section. Okay, so I'm just going to highlight that using the same color that I used for subtraction. Okay, so less than. Something else that stands out to me is the original price. We don't know how much the original price is. That's our unknown number. So that means that's our variable. I'm going to highlight variable. Okay, and then we are also going to be highlighting original price to say that this is something that we don't know, and this is what our variable is. Okay, so after we find the key words in our situation, we are going to define the variable. So define the variable. Okay, so in this case, our variable is the original price. And again, we can assign our variable to be any letter that we want. Okay, you can choose any letter in the alphabet. I'm going to choose P for our variable because I want my variable, the letter that I choose, to remind me what it stands for, and it stands for the original price. Again, I don't want to pick the letter O because it's going to remind me a lot of a 0, and it's going to get confusing. So I pick the letter P. Okay, now, after I've defined the variable, I'm going to model. It's optional, but I want to model because a visual representation helps me. Okay, so my model is going to look like a bar diagram, just like we had in the inquiry lab. Okay, so this bar diagram, it represents my variable. It represents the original price, which we don't know how much it is, so I'm just calling it P. Okay, this is representing the original price. But we know that $6 less than the original price. So we know that whatever we're trying to find, our algebraic expression, the end product, is going to be $6 less than the original price. So if this is the original, I know that it's $6 less than it. Okay, so I'm going to just kind of use another diagram to show $6 less than. So maybe somewhere over there, and this is 6. Okay, so it's $6 less than the original. So here's my original bar diagram, and I'm showing that I'm taking 6 away, okay? By drawing it like this, I'm showing that I'm taking 6 away. So now that I've drawn my model, I can try to represent it with an algebraic expression. Okay, so with the algebraic expression, I want to make sure that I have at least one variable and an operation, right? Because that's what we defined algebraic expression as. So if I look at my work here, I have my variable, I have my operation less than, that tells me keyword search, that tells me that it's subtracted, okay? So I know that my variable P, and whatever I'm trying to find, it's $6 less than, so I'm using subtraction, $6 less than the original, okay? So that's how I would write my algebraic expression, and if I look at my model, I have P here, right? And then I'm taking 6 away from the original. Over here I was taking 6 away from the original. So P minus 6 is an example of my model, and it demonstrates, it translates what I'm trying to say in words, okay? Just for good measure, going to highlight that and this to show that I'm subtracting it, okay? And I'm using orange because in my keyword search I was using orange, just so we keep in mind that we're subtracting. Now, last example, so our second example, four more than 3 times the number of points. Okay, so here's the situation. We have 4 more than 3 times the number of points. So there's a few things that I see there. Okay, this is more of a complex example. First thing I notice is 4 more. Okay, 4 more. That tells me, if I look at my keyword list, I see the word more than, more than. That tells me I'm adding something. Okay, so I'm going to put a blue highlighted box around it to show that I'm going to be adding something. And then I also notice 3 times the number of points. So 3 times, if I look at my multiplication, I have blank times. So that blank be any number. In this case, it's 3 times. So I'm going to use a green highlighter to show that I am multiplying something. And then the number of points, okay, we don't know how many points. It's an unknown number. So since it's an unknown number, that tells us this is going to be our variable. Okay, so first step, just like we did in example 1, is going to be to define the variable. Okay, so if I go over here, I'm going to define my variable. And I'm going to pick n to be my variable. Okay, because it kind of reminds me of the situation. Number of points reminds me what it stands for, number of points. Again, though, you could pick any number that, or any letter that you want to define your variable. Number of points, or represent your variable. Okay, so second step, model. We need to model this situation. So I know that I have 4 more than 3 times the number of points. Okay, so I know that if we look at this first part right here, we have 3 times the number of points. So I'm going to model that first. Here's n, okay? So this is just a model of n so far. And I have 3 times the number of points. Remember, n is the number of points, and I have 3 times that. So I'm going to draw 3 times this. Okay, so now my last step, I'm going to look at what else I have to do for more than 3 times the number of points. Well, I've already modeled 3 times the number of points, so now I need 4 more than this. I'm going to draw 4 there, showing that I have 4 more than 3 times the number of points. So I've drawn a model of the situation. My last step is to write an algebraic expression that represents all of this. So 3, because 1, 2, 3, I have 3 times the amount of variables, which is n. N is my variable, so 3 times n. Remember, this dot means multiply. 3 times n. More than, so more than is plus 4. So there's my algebraic expression. I have 1, 2, 3 n's, so 3 times n plus 4. Okay, and just like we've talked about again, there are multiple ways to show that you're multiplying something. I could have also written this as 3n. Okay, they're right by each other. There's no space, no operation in between. That shows that they're being multiplied. Plus 4. Could have also written 3 with parentheses around the n. Plus 4. That shows that they're being multiplied. Okay. You could also show 3 times n with the time sign. But remember that this looks a lot like an x. And so when we are using algebra now, we use like the letter x as a variable. So we want to stay away from writing this to show that we're multiplying. Instead, we either want to write this, this, or this. Okay, so here we were adding 4 more and then multiplying 3 times the number of points. Okay. So really just follow these 4 steps. Figure out what your keywords are in the situation. Do they mean add, subtract, multiply, divide? Define what the variable is. Okay. Model, which is an option. And then write your algebraic expression. Let me know if you have any questions in class.